Alright, so our objective today is that you solve equations using inverse operations with logarithms. In the last video, we solved equations that had logarithms in them using exponents. This video is going to have equations that have exponents in them, and we're going to solve using logarithms. So just as a quick reminder, the way we're going to do this is everything outside the base here is 3, is going to be gotten rid of first, and then the base, and then everything inside, like the exponent. So we'll get rid of the 8, then the 3, then the plus 4. So the 8 is being multiplied, so we'll start by dividing both sides by 8. That will give us 3 to the power of x plus 4 is equal to 100. And then we need to get rid of this base of 3. Now again, this is not a multiply or divide or an add or subtract situation. To get rid of a base, you use a log. This is the exact opposite of what we did in the last video. So the way we do this is you write log base 3 of both sides. Now, I'm kind of writing it as a diagonal here, just so that log base 3 goes in front, and I'm going to do what I did in the last video. This is saying log base 3 of 3 to the x plus 4 is equal to log base 3 of 100. So, I wrote it out here the long way. Here I just wrote it kind of shorthand, but that's what we're doing here. So the log base 3 and the 3 to the power of cancel out just like the 8's canceled out here. That gives us x plus 4 is equal to log base 3 of 100. Now at this point, we're going to do this on the calculator. This is not a log I would expect you to know. So you hit alpha window, and you go to log base. When you do that, log base 3 of 100 comes out to 4.19. So I showed an extra step here just to kind of show you what we were doing, but you could have done these at the same step. So last step, of course, is to just subtract 4. So our final answer here is x is equal to 0.19. Again, to recap, we got rid of the stuff outside of the base, and then we got rid of the base using the log, and then the stuff that had been inside. Our next problem is a little more complicated looking, but it's the same idea. We're going to get rid of the stuff that's outside of the base. In this case, the base is e. And then we'll get rid of the e using a log. And then we'll get rid of the stuff inside, which is that 1.15. So our first step, of course, is just to add 10 on both sides. This means that my next step is negative 2e to the 1.15x is equal to negative 78. Then we'll divide both sides by negative 2. I feel like you probably knew to do this already, and that's good. These are Algebra 1 skills and not Algebra 2 skills. The new stuff is coming up in the next step. So this gives us e to the 1.15x is equal to 39. Now, to get rid of a base of e, you have to write log base e on both sides. But just like you've been doing for a couple of days, log base e has a special name. So I'm writing ln, that's natural log, on both sides. So ln of this is equal to ln of that. And then the natural log and the e cancel out, and what we get is 1.15x is equal to natural log of 39. And again, just type that into the calculator. 1.15x is equal to 3.66. And you type in natural log of 39. And then our last step, of course, is just to divide by 1.15, and that will give us x. Again, most of this is Algebra 1 skills. The only new part has to do with the logs. When you divide, you get 3.19, and so that is our answer. As I mentioned in the last video, if you would like to check your answer, plug it back into the equation, and you should get something close to negative 88. It'll be a little bit off because we were rounding as we did this problem. So that is it. In this video, we solved equations using inverse operations, and this time we used logs to solve the equation.